All right, so DeepSeek, they've been making headlines with some cool stuff lately, but
Yeah.
let's rewind a bit. Take a look at a paper they put out almost a year ago.
Okay.
I think it deserves a little more attention.
Right.
It's called DeepSeek-VL, Towards Real-World Vision Language Understanding.
Okay.
And it's really fascinating to look at how they're kind of tackling some of the big challenges in the VL space.
Yeah, this paper really stood out to me
Yeah.
when it first came out. What's interesting is that DeepSeek wasn't just focused on achieving state-of-the-art results.
Right.
On benchmarks, which can sometimes be a bit of a vanity metric.
Sure.
They were really interested in building a model that could perform well in real-world situations.
Right.
Which often involves dealing with much more complex and messy data.
Yeah, that's a really important point.
Yeah.
So many VL models, they excel in these like controlled research environments, but then they stumble when they're faced with the unpredictable nature of real-world data. And DeepSeek seems to have recognized that gap
Absolutely.
and made some interesting choices to address it.
And one of the first things that caught my eye was their approach to data construction.
All right.
Instead of relying solely on those well-curated academic data sets,
Right.
they went out and built their own taxonomy of data
Interesting.
based on how models like GPT-4V and Gemini are actually being used in the wild.
Okay, that's clever.
Yeah.
So they're essentially training their model on the kind of data
Yeah.
that it's likely to encounter in real-world applications.
Yeah.
But what kind of data are we talking about here?
Well, they included a really diverse mix.
Okay.
Web screenshots, PDFs, content with optical character recognition, OCR, charts,
Okay.
even stuff like diagrams and code from Jupyter notebooks.
Wow.
They really went all in on creating a data set that reflects the messy reality of the visual world.
I'm guessing that decision to include things like code and diagrams
Yes.
was a deliberate choice to push the model towards real-world code understanding, right?
Exactly.
Okay.
Think about it. If you want your model to understand how code works,
Right.
why not train it on the environments where code actually lives?
Makes sense?
It's a very practical, grounded approach
Yeah.
to model development.
So they've got this robust
Yeah.
real-world data set. What about the model architecture itself?
Okay.
What did they do there to make DeepSeek-VL stand out?
Well, they opted for a hybrid vision encoder,
Okay.
which is a pretty clever design choice.
Interesting.
They combined SIGLIP, which is known for its semantic understanding capabilities,
Okay.
at a resolution of 384 by 384 with SAMB.
Okay.
Now, SAMB is really interesting because it excels at capturing detailed information at a much higher resolution of 4124 by 1024.
Wow, 124 by 124.
Yeah,
That's a lot of visual information to process.
it is.
How did they manage to handle that
Right.
without blowing up the computational cost?
That's the really impressive part. They managed to squeeze all that high-resolution information into a relatively small token budget
Okay.
of 576 tokens.
Wow.
I suspect they employed some clever engineering tricks to achieve that, like using quantization or some form of compression.
It's a delicate balancing act, right?
It is.
You want to retain as much visual detail as possible
Yeah.
without overwhelming the model.
Right.
So they've got the data, they've got this innovative hybrid encoder.
Yeah.
What's next in their recipe
Well,
for real-world VL understanding?
the next key ingredient is their training strategy,
Okay.
which I think is one of the most insightful aspects of this paper.
Right.
They recognized a common problem in VL training.
Okay.
As models get better at vision tasks, they sometimes start to lose some of their language processing abilities.
Interesting.
It's like they're overfitting to the visual modality.
I can see how that would be a problem,
Right.
especially if you're aiming for a model that can seamlessly integrate both vision and language understanding.
Exactly.
Yeah.
So DeepSeek tackled this head on by
Yeah.
using what they call modality warm-up.
Modality warm-up. Okay.
Essentially, they start the training process with a heavy emphasis on language data,
Okay.
using a ratio of 70% language data
Okay.
to 30% multimodal data.
Interesting.
This helps the model develop a strong foundation in language processing
Right.
before it dives into the visual domain.
That's really interesting. It's almost like they're giving the model a head start in language.
Yeah.
So it doesn't get lost in the visual world later on.
That's a great analogy.
Yeah.
And they found that this 70-30 split worked best for preventing that kind of language degradation during training.
Interesting.
It's a simple but effective technique that I think a lot of researchers could benefit from.
Yeah, I bet. So they've tackled data, model architecture, and training.
Right.
What about evaluation?
Right.
How did they measure DeepSeek-VL's performance?
Sure.
And more importantly, how well did it actually do?
Well, they did evaluate it on some standard VL benchmarks,
Okay.
and the results were impressive.
Okay.
Especially for the 7B model, it outperformed most open source models in its size class.
Wow.
And even came close to GPT-4V on certain tasks.
Okay.
But honestly, benchmark results only tell part of the story right. Especially when you're dealing with a model designed for real-world use.
Yeah, benchmarks are great for comparing models in a controlled setting, but they don't always capture the nuances of real-world performance.
Yeah.
So how did DeepSeek go beyond those standard benchmarks?
They did something really clever. They created their own data set specifically for evaluating real-world performance.
Interesting.
And to make it even more interesting, they used GPT-4V, one of the leading closed-source VL models, to help judge the responses.
Oh, wow. So they're essentially using one of the best VL models out there as a benchmark for their own model.
Right.
That's ambitious.
It is, but it also speaks to their commitment to building a model that can truly compete with the state of the art. They weren't satisfied with just beating the average open source model. They wanted to see how DeepSeek-VL stacked up against the very best.
I like that mindset.
Yeah.
So how did it perform? Did DeepSeek-VL pass the GPT-4V test?
It actually did remarkably well, especially in tasks that require a deep understanding of the relationship between vision and language. For example, it excelled in areas like image captioning, visual question answering, and even common sense reasoning.
Wow.
In those categories, it was almost on par with GPT-4V.
That's a huge accomplishment for an open source model.
It is.
That's really impressive.
Yeah.
It sounds like DeepSeek accomplished what they set out to do.
Yeah.
Built a VL model that can hold its own in the real world.
I think that's a fair assessment.
Yeah.
And what's particularly exciting is that they achieved this while being very mindful of resource constraints.
Right.
They actually developed techniques for iterating on smaller models before scaling up to the full 7B model. This means their work is more accessible to researchers who don't have access to massive compute clusters.
That's a huge contribution to the field.
It is.
Democratizing access to these kinds of technologies is so important for pushing the boundaries of what's possible.
Couldn't agree more.
So we've covered a lot of ground here.
We have.
We've talked about DeepSeek's motivations, their data choices, their hybrid model architecture, their clever training strategy, and their impressive results.
Right.
But let's take a step back and think about the bigger picture.
Okay.
What does all of this mean for the field of VL understanding?
That's a great question. I think this paper demonstrates that we're moving beyond the era of simply building bigger and bigger VL models. The focus is shifting towards making these models more robust, more reliable, and more adaptable to the complexities of the real world.
Yeah.
And DeepSeek-VL is a prime example of that shift in thinking.
It's like they're saying, look, we can build models that are amazing at solving benchmarks.
Yeah.
But what's the point if they can't handle the messiness of real-world data?
Exactly.
Yeah.
And I think that's a really healthy direction for the field to be moving in. It's not just about achieving state-of-the-art results anymore. It's about building models that can actually be useful in solving real-world problems.
That's a great point. And speaking of real-world problems, I'm curious to hear your thoughts on what kind of applications this technology could enable.
Sure.
What are some of the potential use cases that excite you?
Well, the possibilities seem pretty endless, right?
Yeah.
I mean, imagine a world where you can use natural language to search through vast image databases. Or control robots in complex environments.
Yeah.
Or how about personalized educational tools that adapt to a student's learning style? Based on visual cues.
Yeah.
It's exciting to think about how this kind of technology could be applied to so many different domains.
Absolutely. And one area that I'm particularly interested in is accessibility.
Yeah.
Imagine using DeepSeek-VL to create tools that can help people with visual impairments navigate the world more easily.
Yeah, that's a great application.
Or imagine using it to develop assistive technologies that can translate sign language into spoken language in real time.
Absolutely.
The potential for positive impact is huge.
It is.
It really feels like we're on the cusp of some major breakthroughs in how we interact with computers and how computers interact with the world around us.
Yeah.
And I love that DeepSeek has made this technology open source.
Me too.
Which means anyone can build on it and explore its potential.
It's a great reminder that some of the most exciting advancements in AI are happening in the open source community.
Yeah.
And it's a testament to the power of collaboration.
Absolutely.
And shared knowledge.
Well said. So as we wrap up, is there anything else that stood out to you about this paper? Any key takeaways that you think our listeners should keep in mind?
I think the biggest takeaway is that real-world performance matters.
Okay.
It's not enough to build models that excel in the lab.
Right.
We need to be thinking about how these models will perform in the messy, unpredictable complexity of the real world. Yeah. And DeepSeek-VL is a great example of how to approach that challenge thoughtfully and effectively.
It's a powerful message, and I think it resonates with a lot of people
who
are looking for ways to make AI more relevant and impactful in their own lives.
Absolutely.
So to our listeners, I encourage you to check out the DeepSeek-VL paper and see for yourself what they've accomplished.
Yeah, great paper.
You might be surprised by how much innovation is happening in the world of open source AI.
And who knows, you might even be inspired to build something amazing with it.
Right.
The possibilities are out there waiting to be discovered.
And on that note, we'll wrap up this deep dive into DeepSeek-VL.
Great. Thanks for having me.
Thanks for joining us.